Okay, now here I want to talk about the instantaneous speed. Now this is very important. Instantaneous speed. What is that? All right, instantaneous versus the average speed. Okay, now we have learned about the basics of speed, the formula unit. That now you want to understand what is the difference between instantaneous speed and average speed. Now let me just give you an example here. Let's say you are driving to, school. Let's say lah, okay, and your school is how far away? Let's say it's 5 km away. Right now, 5 km away. Now during your journey, right? During your journey, okay, let's talk about instantaneous speed first. Okay, now during your journey, you don't maintain the same speed like throughout your journey, right? Let's say it takes 30 minutes, okay, 30 minutes to travel from your house to your school. Okay, now during these 30 minutes, you won't maintain your speed. Maybe you will, but most of us won't maintain the same speed throughout 30 minutes, right? Sometimes we speed up, sometimes we slow down, and sometimes when we see red light, we stop our car, right? So the key is that you keep changing your speed throughout the journey. Okay, your speed is not fixed; it keeps changing. So maybe at this, wait, we are having some. Brandon Wong is kicked out. Wait. Let me just send him the link. Just a second, guys. Okay, he's here. Okay, Brandon, you just got disconnected, right?
Yeah.
Okay, let's continue with the lesson. Okay, now I'm going to repeat a little bit. Now, let's say you're driving to school 5 km and it takes 30 minutes, okay? Now, you don't necessarily maintain the same speed throughout the journey. Sometimes you speed up, sometimes you slow down. And in heavy traffic, you slow down. When you see red light, you stop your car, and sometimes you accelerate. Okay, so the point is that at every particular instant of time, okay, you are traveling at different speed. Let's say at this point in time, you are traveling at 50 kilometers per hour. And the next few seconds, you change your speed. You're traveling at 70 kilometers per hour. Okay? Now, instantaneous speed is the speed at that particular point in time. Okay? Meaning that if I take this one as point A and point B, okay, now at point A, your instantaneous speed is 50 kilometers per hour. It's the speed at that moment in time. All right, it is also the speed that is shown in your speedometer. This one, right? 50 kilometers per hour. So you see this one, your speedometer. This is keep changing, right? This keeps changing, right? If you increase, it increases. If you decrease, then it decreases, right? So that is instantaneous speed. It is the speed at that particular point in time, right? So at B, what is your instantaneous speed? Now it changes to 70. All right, so this is instantaneous. Now, instantaneous is different from average. Now, what is average? Average, we only interested in the overall journey. Okay, the overall journey, meaning that we are only taking the starting point to the ending point. Where is the starting point? Let's name it as point X here, starting point. Ending point is here, point Y. All right, now average speed is the total distance traveled divided by the total time. Okay, let's start from the speed formula first. S equals to d over t, correct? Okay, S equals to d over t. So we only interested in the total from the starting point to the ending. So what is the total distance that you travel? 5 km, right? 5 km. So I put 5. And what is the total time taken? Total time taken is 30 minutes. 30 minutes is equivalent to 0.5 hour, right? Because 1 hour is 60 minutes. So 0.5 hour is 30 minutes, right? So 0.5. Now, 5 divided by 0.5, what do you get? 5 divided by 0.5, you get 10, right? So 10, the speed is 10 kilometer per hour, meaning that this is your average speed. Average speed, as the name suggests, right? Average, meaning that you're not, you don't care about like this. At point A, you're traveling at 50. At point B, you change your speed. You don't care about all that. You're only interested in the overall journey. You're moving at 10 kilometers per hour on average. All right. So can you see the difference between here? Can you see the difference? Average is just you take the total distance divided by the total time between the starting and ending point. But instantaneous speed is the speed at point A, point B, and it's different from the average speed. Okay, now somebody has a question here. Okay, okay, yeah. Go. You can go. Okay, so any question about average and instantaneous speed? Okay, now average speed is the same formula, same formula, same speed formula, just that the distance is, we take the total distance, and the time taken is the total time taken. Later I'll show you one example of how to find the average speed. Okay. Okay, now 1 minute, jot down this one, and I'll show you the last example, then we'll wrap up for today. Take this down. Okay, I can label instantaneous speed as, I write down here for you, the speed at a particular point
Teacher,
in time. Yes?
when we go back to school, right, is the times gonna be the same every single day to come to school, like 11 o'clock?
Yeah, 11 o'clock. Anybody not going back to school next week?
I'm going back to school.
You're going back, huh?
Teacher, I think I don't think I can go back to school
Your parents don't
because
allow?
my parents, I think, they know this is dangerous. Still, I mean, of the coronavirus.
Okay. Did you like contact the Mr. Lim, the principal?
I think my father handled it. My
Your
father.
father handle it. Okay.
Yeah.
I think we'll see the majority, because uh you guys we'll see the majority. If majority of the parents don't allow their kids to go back, then maybe we'll keep on doing the online. But most probably we are going back next week lah. Okay. So far there's no announcement, something like that. Okay, so majority. So if you're
Wait, teacher, if the majority said they allow the students to go back to school, then how about the majority? How about the people that don't allow the students to go back to school?
then we'll do the hybrid. It's like we are in a physical class, so at the same time we will do the online at once, like simultaneously. Okay, so it's like I'm talking to the class, I'm talking to the computer in the class, and then the computer will project the screen onto the board. Okay, at the same time for the online students and for the physical class students. It's
Wait,
like
teacher, you
hybrid.
can go back to school, right? You're not quarantined anymore in your house, right?
I have like 5 days until the end of this week. So if anything goes wrong in the, by the end of this week, then I have to extend. But so far, it's okay lah. So only until Sunday. Until Sunday, I quarantine until Sunday. Okay, I'm just going to erase this and
Wait,
then
so how are you said you have to quarantine, so how are you supposed to eat?
eat. I just call the Grab Food, Food Panda, all that. I'm not like fully 100% quarantine. So it's like 80%. So sometimes I go out and get something, but have to be very careful lah. Wear mask all the time, all that. Okay, let me just you guys can copy down this example, okay, and then I'll show you the working at once. All right, now let's look at number one. Okay, here you have a diagram showing an object moves from destination A all the way to D. Okay, now it's showing the speed and distance for reaching each destination. Right, so he's traveling at different speed. Throughout the journey, he's traveling at 3 different speeds. Okay, so it's 3 meters per second, 2 meters per second, and 4 meters per second. Now, number one, what is the time taken to reach each destination? So we have to calculate separately each destination, right? So from A to B, let's calculate from A to B first. A to B, the speed is 3, distance is 30. So you put S equals to D over T, right? So 3 equals to the D over time. Okay, 3 over 30 over time, and then T equals to 30 divided by 3, and that equals to 10 seconds. Okay, so from A to B, I write down here, the time is 10 seconds. Okay, so we are only interested in A to B, so we don't look at B to C and C to D. Okay, now we look at B to C. Okay, B to C, speed equals to D over time. So 2 equals to 50 over time. And time equals to 50 divided by 2, 25 seconds. Right? So B to C, the object takes 25 seconds. And finally, from C to D, speed is 4. Distance 60, and find the time. So time equals to 60 divided by 4. Okay, 15 seconds. So C to D, it takes 15 seconds. Now, remember just now the instantaneous speed and average speed. So this is the instantaneous speed. This one, 4, 2, and 3. It is the instantaneous speed at that moment. Okay, when the particle is traveling from C to D, the instantaneous speed is 4. Now, number 2, what is the total duration of the journey? So you just plus all the time taken. Okay, so from A to D, duration is the time, total time is 10 plus 25 plus 15. Okay, and then you get 50 seconds. 50 seconds total time. Now, number 3, what is the total distance traveled? Then you total up the distance. Okay, distance equals to, from A to B is 30 plus B to C is 50 plus C to D is 60. So it's 140 meter. Now, last one, what is the average speed of the object? Now, average speed, remember I said average speed, we only look at the overall journey from the starting point, which is A, all the way to D. Okay, so average speed is not the same as this one shown in the diagram, 3 meters per second, 2 meters per second, 4 meters per second. So it's not the same. Those are the instantaneous speed. Now we want to calculate the average speed. So S equals to D over T. The distance, we take the total distance. Remember, just now I said we take the total distance divided by the total time, right? So the total distance is the one that you calculated in number 3, all right? So 140 total divided by the total time is the one that you calculated in question 2, 50. So equals to 140 divided by 50, you get 2.8 meter per second. This is the average speed. So you see 2.8 average speed is not the same as 4 meters per second, 3 meters per second. So sometimes from A to B, the particle is moving, the object is moving more than 2.8. B to C is 2 less than 2.8, and C to D is way more, 4 meters per second But on average, it is moving at 2.8 meter per second throughout the journey. Okay, so you can label this as just right here. This is average, and all this instantaneous. Now, what if it says? What if the question says that the object stopped at C for 2 hours? Let's say lah, not 2 hours lah. Let's say 10 minutes. 10 minutes is about. Wait, let me just. Okay, stop for 60 seconds. Let's say the object stopped at C for 60 seconds before continuing its journey. Then how do you calculate the average speed? Average speed here, the time you have to plus another 60 seconds. Okay, so you have to take into account when the object is resting. Okay, because it is part of the journey. If the object, it says that the object rests for 60 seconds, you have to plus that one also. You have to count that one also. Okay, we have less than 1 minute before we get kicked out. Copy down this one, and if you don't manage, then please take a snapshot before we lose this one.